Hello people, so today we'll be on LeetCode DailyQuestion, but before that I would like to be apologetic for the yesterday's mic quality. I got to know about it later when I was recording the reel that there's some issue with the mic, and I am being a little bit shameless, so please subscribe to the channel and hit the like button, drop your comment, and without wasting any time, let's just dive into the video that is the lead code question 947, most stones removed with same row or column, and in this we'll be on a 2D plane. We have n stones at some integer coordinate points, and each coordinate point may have at most one stone, and a node and a stone can be removed if it shares either the same row or the same column as another stone that has not been removed yet. Okay, so we'll be given an array of stones of length n, where stone size is equal to xi yi, represented being location of the ith stone in the xy plane basically, and we have to return the largest possible number of stones that can be removed. For example, in this we are having the stones array as 0 0 0 1 1 0 1 2 2 1 2 2. So what we can do is we can basically start from removing 2 2 because it's in the same row as 2 1. Then we can remove the stone 2 1 because it's in the same column as 0 1. Then we can remove the stone 1 2 as it's in the same row with stone 1 0. And then we can remove the stone 1 0, it is having the same column as 1 0. But we can remove stone 0 1 as well because it shares the same row as 0 1. But we cannot remove the 0 0 stone because at the end it will not be sharing any of its row or column with any other plane. Okay, so this question boils down to the question of finding the most common parent of all the nodes, and that will not be removed. Okay, so for this we'll be needing a distance set union. So let's have a union array, let's call it unions. So that is equal to new int of size 1000 because that's what the constraint states. Okay, so xi yi, yeah, length of the stone is 1000, so yeah, that would perfectly work. Oh, it's from 1 less than or equal to, yeah, so again that will work. Then let's have first n that is equal to length of the stones. Then we'll be initializing that for every current point its parent is it is its own parent. Okay, so for int I equal to 0, I less than n, I plus plus, then we'll be doing unions of I uh, is equal to I. Okay, now what we'll be doing is we'll be basically doing two nested loops for int I equal to 0, I less than n, I plus plus. Then for int j equal to j equal to I plus 1, j less than n, j plus plus, we'll have to check that if it either shares the same row or the same column. So if stones I0 is equal to stones j0 or stones I1 is equal to stones j1, so that means it is having the same parent, and we'll be combining it by using calling the merge function. In that we'll be passing the indexes I and j. So let's first quickly write this merge function. So private void merge, it's having int x and int y. Okay, now what I'll be doing is firstly basically I'll be finding the parent of x, so I'll be passing find x, and I'll be updating the y with the parent of find y, and then I'll be checking that if x is equal to y, it means both are having the same parent. In that case I have to return. Then I'll be updating that unions of y is equal to x. Okay, so after this I'll be merging them into one. Oh, okay, let's write the find function as well. So private int find here, let's say if I'm having int x, so I'll be returning that if unions of x is equal to x, that means I have found the parent. Then I'll be returning x, otherwise I'll have to return the function called find with the union of x. Okay, and at the end what I'll do is I'll be checking that the number of nodes which are having the parents as themselves, basically the ith index which are having the parents as itself, that's the number of stones which will not be removed. Okay, so int, okay, yeah, int count that is equal to 0, and for int I equal to 0, I less than n, I plus plus, then if unions of I is equal to I In that case, I'll be incrementing the count. Okay, so at the end, my answer of the number of stones that are removed will be n minus count. Okay, so now let's give it a run. Yeah, and it gets accepted. Now let's submit it, and works perfectly fine, and it gets accepted as well. Okay, so this was for today. Thank you for watching.